Okay, so here we'll be looking at Newton's third law of motion. And this law states that to every action there is an equal but opposite reaction. So Newton's third law finds expression in the following application. So recoil of a gun, you shoot a gun, it recoils backward. I didn't make provision for pictures. Jet and rocket propulsion is another example. So walking on the road actually is another example. Then lift is another example. Okay, so here we see a question here. A gun of mass 2.0 kilogram fires a bullet 160 grams due east. If the bullet leaves the nozzle of the gun with a velocity of 150 meters per second, what is the recoil velocity of the gun? So whenever you're asked to calculate recoil velocity, we use this formula because the momentum of the bullet is equal to the momentum of the recoil. Okay, so M1U1 is equal to M2U2. So your M1, which is the mass of the bullet, is 2. Okay, sorry, the mass of the gun. U1 we don't know, that's the recoil. Equal to M2 is the mass of the velocity and the bullet. The mass of the bullet is 160 grams, which is 0.16 kilograms. Then U2 is the velocity of the bullet, which is 150 meters per second. So by the time you multiply that, you get your U1 to be 1.2 meters per second. So the recoil of the gun is 1.2 meters per second. So don't forget that the Newton's third law of motion is actually based on that principle. Now here, a rocket expels gas at the rate of 0.5 kilogram per second. If the average force of the gas is 100 newtons, calculate the velocity of the gas. Calculate the velocity of the gas. Now, as usual, force is equal to mass times velocity over time. That's according to Newton's second law. So the force is 100. The mass rate is 0.5 kilogram per second. That's mass over time. Then velocity is v. So your v is 200. Please note that m over t is 0.5 kilogram per second. From the unit you see that, and that's the mass flow rate of the gas. Okay, so